Hello everyone, welcome back. In this presentation, we will focus on the acoustic challenges and opportunities in the sediment management. So we'll start with a quick understanding of the acoustic systems and their working, and then we'll move forward exploring what are the various gaps and opportunities in the acoustic segment. With the rapid advancement of the sonar devices and signal processing technology, there has been a great potential for acoustic methods in imaging the seabed ecosystems. Various instruments, which include the multi-beam echo sounder, sub-bottom profiler, and side scan sonars, have been developed to gather the observational data for comprehensive study of the sediment dynamics. Now, there is a choice between the various ranges and resolutions of these devices, and again, these systems can be mounted on various vehicles based on our needs, like the AUVs or the ROVs. Now, typically, the drilling vessels have basic soil testing equipment for testing and characterization of the seabed directly by taking out samples. Also, the propagation mediums such as salinity, temperature, and density influence the effectiveness of the acoustic system. Now, during the First World War, the submarine technology advanced significantly. An object could be detected by using a transmitter and a receiver using the sonar system. Now, the transmitter produces and transmits a powerful ultrasonic waves, which then travel through water, and then after they strike the particular target, the beam is reflected back from the target or the seabed in our case, and is received by an underwater detector, which could be mounted on a ship as well. So this would be a brief way of working of the underwater sonar system. Then, when we consider the tropical conditions, the challenges of the particular unique conditions significantly impede the effectiveness of acoustic systems. The warm and saline waters in the deeper channels impact the sound axis depth that influences the sound transmission between the surface and the bottom. In tropical waters, this sound channel is deeper, which affects the acoustics and hence reducing its effectiveness to just 60 to 70%. The warm coastal waters also cause additional distortions in acoustic signals due to multi-part propagation, which further impede the performance of sonars used for underwater monitoring. So our acoustic sensors, they are available in a broad range of configurable frequencies, which often combine the various high and low frequencies. So the selection of these frequencies depend on what kind of purpose the sonar or the sensor is intended, such as locating specific objects or assessing seabed conditions or conducting wide area searches. The searchable depth and area depend on the chosen frequency. So a high frequency ultrasound would be suitable for detailed searches but not for deep water exploration, while a low frequency ultrasound would be ideal for general searches in wider areas and deep water exploration. There are also dual frequency transducers which would facilitate accurate and wide area detection. But again, when we come to the development of these acoustic sensors, the tropical conditions pose a lot of challenges. First of all, a lot of economic activities in the region generate anthropogenic noise such as engine noise and seismic surveys, which can disrupt the essential sonar signals and interact with noise sources. Then the Indian Ocean also hosts underwater cables which transmit large volume of international data and contribute to sonic interference, hindering the effective sonar operations. Now, despite the technological advancements, providing these precise measurement tools for monitoring has faced various challenges. Factors like the background noise interference, encompassing various natural and human made elements, make it difficult to isolate and detect specific acoustic signals. The ocean conditions like temperature, salinity, and pressure changes affect the sound speed and propagation, which introduce variability in the calibration and maintenance of equipment. Again, this maintenance of equipment can be technically and logistically challenging and expensive, which would impact the data accuracy and reliability. There are constraints related to equipment and operational cost, which include the acquisition, continuous measurement, and maintenance of specialized equipment, various kind of data analytics, and personal training, which can again impede the sonar performance. But why do we talk this all development of sonar or the acoustic sensors in the Indian Ocean? Then that is very much crucial to understand. The Indian Ocean region lacks the substantial technological expertise and well-established scientific foundations, which necessitate urgent efforts to incorporate new technologies and conduct comprehensive explorations. Now there is limited financial resources and insufficient government support, which force many regions to depend on more developed Western nations for their acoustic sensors to gather data. Relying on these Western firms, particularly in area like acoustic sensors and sonars raises concerns about the sharing of strategic data with non-state actors. The dominance of Western climate science hampers comprehensive research on the Indian Ocean region. Thus, the lack of proper funding and research and development has affected operations of the business sector as well. But despite the various challenges, the Indian Ocean region has a lot of opportunities in the acoustic sensor development. For example, in July 2023, the Indian state-owned shipyard Garden Ridge Shipbuilders they marked a significant achievement by launching the AUV, which named Nirakshi. Now, this is crucial because it helped India to enhance its underwater capabilities, as it has applications ranging from mine detection to underwater surveys and all. Similarly, companies like Larsen and Toubro are actively contributing to indigenous development of the unmanned underwater vehicles and have like recently it has showcased its newly developed drones at the Defense Expo as well. So there are a lot of opportunities for the private sector as well and the public sector undertakings also. Thus, the development of these autonomous underwater vehicles (AUVs) equipped with the advanced underwater acoustic sensors is rising, which play a crucial role in the exploration, environmental monitoring, and underwater surveillance. Integration of AI and machine learning techniques is also becoming essential to process large volumes of data. India aims to establish the robust foundation for integrating this acoustic sediment monitoring into the environment management, policy making, and scientific research. This would include training and educational programs designed to equip scientists, researchers, and marine professionals with the necessary knowledge and skills for effective acoustic sediment analysis. There could be also data collection, processing, and distribution to interpret the acoustic data accurately and draw meaningful conclusions. Thus, by fostering collaboration, sharing best practices, and supporting research initiatives, we can build a holistic acoustic capacity. In this, we could use the 2C to share to understand and to share a concept to develop our acoustic capability. So the immediate physical layer of 2C is where we would require the development of sensors and the hardware to map the entire region and high performance computing processors. This infrastructure initially could be imported at a high cost due to its strategic value, but once developed, it would help in creating a proper acoustic sensor ecosystem which is catered to the regional conditions. Then there would be the to understand mechanism. It would have two aspects. One would be data integrity, that is minimizing errors due to data corruption, and then the other is the analysis capability to make meaningful interpretations from the data. The error mitigation would require a significant understanding of the local conditions related to the noise and medium fluctuations. Then the analysis capability would also require large amounts of data processing capabilities, integration of artificial intelligence, cloud computing, machine learning, and all of this new modern technologies. And both aspects would involve large-scale oceanographic studies and acoustic surveys. Then the third category would involve the to share, which would involve sharing real-time information with the multiple stakeholders to prompt timely responses. Acoustic capacity would aim to gather substantial data on local conditions to reduce errors and improve data analytics capabilities. Again, in this condition, developing algorithms for data processing among the various stakeholders would be a crucial capability. For example, noise would be important criteria. So for military use, the signal from an adversary is desired and any other signal is considered noise. While for a marine biologist, this biological signal is of interest while everything else is considered noise. Also the time scale of the data. So for example, a policymaker would require data spanning decades, while the Navy or the defense forces would require real-time data for deployment of the strategic assets. So that also needs to be understood, and to we need to create a proper connected interface in order to store and share this data. Thus, this we could work upon the outreach, engage, and sustain model as developed by the Maritime Research Center and the Underwater Domain Awareness Framework. So with this quote, I'll end the discussion here.